Hey guys, today we're going to be talking about substituted alkanes. So the first thing that we'll talk about is what is a substituent or a substitution. And that is an atom or group of atoms attached to a carbon chain. So this is often also called branching. Let's write that down. So what all this is meaning is that off of the main chain, you have something branched off the side. If it only has your straight normal chain, then it's called a linear alkane. Okay, so continuing on, so an atom or a group of atoms attached to a carbon chain. So for example, this chlorine here is a substituent. It is something off of our main alkane chain. We can have a variety of different types of substituents, but the two that we're going to talk about are haloalkanes, which are halogen substituents, and then alkyl groups, but we'll get to that in a second. So examples of a haloalkane, we could have a fluoro group. Notice how this is a prefix. You see my little dash. So fluoro, it's not a fluorine group, it's a fluoro group. We can also have, a chloro group, or bromo, or iodo, then iodine. So those are examples of haloalkanes, or substitutions of halogens on an alkane. And then we can also have alkyl substituents, I can't say the word right now, which are carbon branches attached to carbon chains. So for example, we could have a methyl group that comes off of our carbon chain. So you notice how we have our linear alkane that I have in black, and then you have another carbon coming off of it. That is a branched carbon, and since there's only one carbon, we're going to have meth as our prefix, and then YL means that it's a substituent. We could also have an ethyl group. So eth means two carbons. So we have two carbons off of our main chain. So we have eth for two carbons, YL signifying that it's an attached part. Propyl is the same thing. So we're going to have three carbons, 1, 2, 3. Let's number these guys. 1, 2, 3. 1, 2, and 1. So we have three carbon chain off of our main chain. That is a propyl group. And then lastly, we can also show what the shape of the group off of our main chain is. For a propyl group, for example, doesn't have to necessarily be a chain straight off of there, but we could have something like an isopropyl group, where we still have three carbons, but now they're in a Y shape. So they're connected differently, but there's still three carbons. So we call this isopropyl group to show that shape. These are, I believe, the only substitutions, at least carbon substitutions, that you will need to know the names of specifically. So looking at naming our substituted alkanes, the first thing that we're going to do is we're going to write the alkane name of the longest carbon chain. So you'll notice sometimes if you number differently, you can have different chain lengths. You want to find the longest continuous carbon chain, and that's going to be your alkane name that you write. Number the carbons from the end nearest to the substituent. So what this means is that when we number our carbons, we're wanting to try and get our substituents, or the things hanging off of it, to be at the lowest numbers possible. And then number 3 is give the location and the name of each substituent in alphabetical order as a prefix to the main chain. Okay, so let's try an example. Oh, I've missed a little star here. If there are more than one of the same substituent, you're going to use additional prefixes such as di and tri. So we'll show examples of that in this first example, actually. So our first example, what is the longest carbon chain? So in order to do this, we're going to need to number our carbons. So the reason I have a couple of this molecule drawn out right here is to show you how you could number this molecule differently. You could number, for example, 1, 2, 3, 4, just straight down from left to right. You could also number it the other way, 1, 2, 3, 4, still at 4 carbons in a continuous line. Or in this particular case, you could go vertically, 1, 2, 3, 4. There's a lot of different ways that you could number this. They are all still correct. In this particular molecule, it doesn't matter which way we're going because it's fully symmetric. So our longest carbon chain is 4 carbons. Next step is to number the carbons of the chain. In this case, it doesn't, as I said, it doesn't matter exactly where you start numbering because it's symmetric. I'm going to just go ahead and use my first example over here. Identify my substituents. So how I like to do this is I like to circle my substituents so that I can see the number of the carbon that they're on and what they are. So identify substituents, I did that. There's 2, why did I do that? 2 methyl groups. And where are they? On carbon 2 and carbon 3. So in order to put my full name together, I'm going to start with my alkane longest carbon chain and the name for that. That's going to be the end of my name. So since we have 4 carbons here, it will be a butane chain. And then as prefixes, we'll add what substituents are off of that butane chain. So in this case, we have 2 methyl groups. So we have to write dimethyl. So this is the example up here of where it says when you have multiples of something, you have to write how many, use the prefix. So we'll have 2 methyls, dimethyl. It's right before you put butane. And then also before that, we're going to need to say where those methyl groups are. So I'm going to write 2, 3 dash. That means that there's a methyl group at the 2 position and a methyl group at the 3 position of my butane chain. Okay, so that's our first example. Let's do a couple more before we get into doing this on our own. Okay, our next example. What is the longest carbon chain here? So we can number it 1, 2, 3, 4, 5. We could also, instead of doing the 5 down, we could do the 5 up, whichever one's fine. But it looks like we have a carbon chain that is 5 carbons long. Number the carbons of the chain starting with the carbon closest to a substituent. So I'm going to circle my substituents. I have one here. We're going to say that my numbering went that way. I have one there and I have one here. So keeping my numbering exactly as it is, you'll see that I have substituents at 3 and 4. However, if I turn the numbering around, then I have substituents at 1 and 2, or I'm sorry, 2 and 3. So let's try that. I'm going to erase these numbers that we have and put them the opposite direction. Starting over here, 1, 2, 3, 4, 5. So what this shows you is that you can put the substituent, and you can go backwards to put the substituent at the lowest numbers possible. Okay, so we did step 2. Got it. Identify our substituents. So I'm going to go ahead and put their location and what their identity is. So I'm going to write, we have a 3-chloro and we have a 2-methyl. So remember that methyl means 1 carbon off of your main chain. And then the last step is to list them alphabetically as a prefix. So up on the top here, let's start with our main alkane chain name, which is pentane, because we have 5 carbons. And then we have to add in 3-chloro and 2-methyl. So we're deciding between chloro or C and M. So our chloro, even though it's at position number 3, we go by ABC order. Chloro comes before methyl. So the final name will be 3-chloro, and in between substituents, we'll put dashes, dash 2, dash methyl pentane. Okay, so that's our final answer there. Starting to get the hang of it. Let's do one more example. First thing is we're going to see what our longest carbon chain is. It looks like it's just right down the middle. So let's number it and see how many there are. 1, 2, 3, 4, 5, 6, 7 carbons long. So we know that we're going to have our base chain name be heptane, meaning 7 carbons long. Okay, and then we need to identify our substituents, make sure our numbering is the right way. We have 1 at 3, 1 at 4, and then 2 at 5. So this is a little tricky because if you turn our numbering around, you're still going to have something at 3, something at 4, and something at 5. However, if we do turn our numbering around, then we have 2 at 3 instead of 2 at 5. So that is going to be the better choice. So I'm going to switch my numbering to go the other way. Again, that is to make sure that my numbering on my substituents is the lowest possible numbering that I can have. Okay, so now let's write out what our substituents are. I have the fancy technology of this iPad, so I'm going to cheat a little bit. I'm going to write, I know I have 3 chlorines, so I'm going to write trichloro. I'm going to put a dash and write where they are. So there's 1 at 3, 1 at 4, and 1 at 5. Then I also have, let's move this a little bit, squished. Then my other substituent I have is a methyl group at the 3 position, 3-methyl. So now the question is, what is the ABC order? So you'll see this little star down here with a little caveat. Alphabetical ordering by the main part of the prefix. So multiples like di or tri, or even the shape like iso for isopropyl does not count in the ordering for that ABC order. So we're actually comparing chloro, C to M. So even though it's tricky, we have trichloro. That trichloro actually comes first. So how I'm going to cheat is instead of rewriting this, I am going to just move this over because chloro comes first. So we will have 3, 4, 5 trichloro 3-methyl heptane as our final answer. This is where we're going to stop, and I hope you guys have a chance to go to the next couple slides and practice this, and we'll work on this together some more.